What exactly is the T-substitution, and how can we use it to evaluate the integral of 1 over sine of theta or 1 over cosine of theta with respect to theta? Hi there and welcome to MWF. In this video, I want us to develop together the T-substitution by following the steps in this flow chart here. And then once we have developed the T-substitution, we go ahead and use it to evaluate these two integrals here. But first, let T equal to tan of half theta. Now, this immediately creates a right-angled triangle whose angle here is half theta. The opposite side is equal to T. The adjacent side is equal to 1. So that tan of half theta is equal to T over 1, which is equal to T. That's what this means down here. Right. What about the other side? We've got the adjacent side equal to 1, the opposite side equal to T. What about the hypotenuse? Well, using Pythagoras' theorem, we have opposite side AC is equal to the square root of 1 plus T squared. Now, we have one trigonometrical ratio here, which we have said is T tan of half of theta is equal to T. What about sine of half of theta? From our triangle here, we have sine of half of theta is equal to opposite over hypotenuse, which is equal to T over the square root of 1 plus T squared. Cosine of theta is adjacent over hypotenuse, which is 1 over the square root of 1 plus T squared. So cosine of half of theta is equal to 1 over the square root of 1 plus T squared. Right. But our problem here is that we are not using cosine of half theta or sine of half theta. The angles we want to integrate are sine of theta and cosine of theta. So what's the relationship between cosine of theta and cosine of half theta? Sine of theta and sine of half theta. Well, sine of theta is equal to 2 sine of half theta cosine of half of theta. Using our formulas here, we have this is equal to 2 brackets. What is sine of half theta? It is that, which is T over square root of 1 plus T squared, all squared, brackets multiplied by this one here, which is 1 over the square root of 1 plus T squared, all squared. I hope you can see my handwriting. It's looking too tiny there, isn't it? And let's simplify. This is whole squared. This is all squared. This simplifies to 2T over 1 plus T squared. So this is our sine of theta. What about cosine of theta? How is it related to cosine of half of theta? We know that cosine of theta is equal to cos squared half of theta minus sine squared half of theta. Plugging in our formulas here, this is equal to, what is cosine half of theta? It's that one there, so it's 1 over the square root of 1 plus T squared, all squared, minus brackets, sine squared is T over the square root of 1 plus T squared, all squared. And this simplifies to 1 minus T squared over 1 plus T squared. That's what we have here. Cosine of that is equal to that. The sine of this is equal to that. So let's just circle our formulas here. That's our sine. That's our cosine here. Let's circle it nicely. So what about d theta? Well, we have t is equal to tan of half of theta. Let's differentiate both sides with respect to theta. We have dt over d theta is equal to half sec squared half theta, which is equal to half of brackets. Remember, sec squared theta is equal to 1 plus tan squared theta. So this becomes 1 plus tan squared half of theta. But what is tan of half of theta? It's equal to t. So we can write this as half of 1 plus t squared. So if this is the theta, then we have dt d theta is equal to half of 1 plus t squared. Let's cross multiply. That finally gives us 2 dt over 1 plus t squared is equal to d theta. That's what we have here. So d theta is equal to 2 dt divided by 1 plus t squared. Now we are ready to integrate our two integrals here, because our cosine theta is equal to this, our d theta is equal to that, our sine of theta is equal to this, our d theta is equal to that. So the first integral becomes integral of d theta over cosine of theta is equal to the integral of, remember, d theta is equal to 2 dt over 1 plus t squared divided by our cosine of theta, which is 1 minus t squared over 1 plus t squared. This just simplifies to the integral of 2 dt over 1 minus t squared. You can do the algebra there. It's just a matter of turning this thing upside down. What about our sine of theta? The integral of sine of theta, we have our d theta here over sine of theta, and we can write this as 2 dt over 1 plus t squared, all divided by our sine of theta. Remember, it's 2t over 1 plus t squared. I'm crowding out things here, isn't it? And that simplifies to, when you invert the bottom formula there, the bottom fraction there, that simply gives you your dt over t. That's your second integral. And this is your first integral. That's how we use the t formula. Till we see you next time. Please take care and bye-bye.